I want to show you a very grievous mistake that most WAEC students are going to make in these chemistry practicals. And that is what you have on the board. So I don't want you to make that same mistake. I want you to keep focused on this to the end of this video, and you'll be able to escape that mistake that a lot of students make. After they have mastered the different formula, the equations to use, and they are very confident when they get into the exam hall and they make that slight mistake. Look at this question. There are two questions on the board. I'm going to show you because that is exactly what they will give you in the exam. You will see something like that in the exam, and many people will make that mistake. This question says A is a 0.050 mole per dmq of HCl. So what does this value represent? It represents the concentration of acid. Abi, what kind of concentration? Molar concentration, or concentration in mole per dmq. 0.050 mole per dmq of HCl. Now see this, B is a solution of sodium hydroxide containing 0.025 moles per 250 cm cube of solution. So I was asking some students, what does 250 cm cube represent? So it's our what? Most students said VB is 250 centimeter cube. Why? Because they said the B is a solution of sodium hydroxide, this is the base, containing 0.025 moles per 250 cm cube of solution. So they just said the VB is this. This is wrong. This is wrong. This is a major mistake that most students make. This is not the VB, and this of course is not the molar concentration of the base. Are you with me? Molar concentration is the amount in moles present in 1 dmq. So your VB in most schools will be 25 centimeter cube, because that is the volume of your pipette. That is what you're going to use for your pipette, okay? Not this 250. So what are you supposed to do with the 250? You're supposed to write this out. 0.025 moles is present in 250 cm cube. You now say X mole is present in 1 dm cube. 1 dm cube is the same thing as 1000 centimeter cube. So it is this X you will find. So the first question they can ask you here is what is the molar concentration of the base, CB. So for you to get the CB, if you just say CB is 0.025, you are wrong. If you say your VB is 250 cm cube, you are absolutely wrong. So the right thing to do here, when you cross multiply, you have X times 250 is equals to 0.025 times this 1 dm cube. All right, 1 dm cube. But you need to convert this centimeter cube to dm cube. So you divide this by 1000. 250 divided by 1000. So you're going to have X times 0.25 in dm cube now equals to 0.025 times 1. So you divide both sides by 0.25. Divide it by 0.25 to be able to get your X. So your X, by the time you divide this by this, okay, you are going to get your molar concentration in mole per dmq of the base. So let's divide this. When you do this division now, this gives you 0.1 moles per dmq. So that is the molar concentration of B, not 0.025 moles per 250 cm cube. This is the molar concentration of the base. Now look at this second question. A is this is the molar concentration of the acid. The volume of the base, like I said, will always be your VB, is not this 500. Look at it. Solution of an acid. B is a solution of KOH containing 2.8 grams per 500 cm cube. Some people will say this is VB. It is not. This is not the VB. Your VB is the volume of the pipette that you use, which is going to be 25 centimeter cube for most schools. For some, it could be 20, but for most schools, it will be 25 cm cube. So this is not the volume of your base. Rather, this is what you use to calculate the concentration of the base. So how are you going to do that? They said B is a solution of KOH containing 2.8 grams per D. So that's going to be 2.8 gram present in 500 cm cube of this base. So you now say X gram is present in 1 dm cube. So you have to convert this to dm cube. That will be 500 divided by 1000. That's 0.5. So that is now going to be what? 2.8 gram present in 0.5 dmq, x gram is present in 1 dmq, then you cross multiply. So when you cross multiply, you have 0.5x is equals to 2.8. Divide both sides by 0.5. Okay, so that's going to be 5.6 grams per dm cube. So this is grams per dm cube. It is the mass concentration of this base. The reason why here was mole per dm cube is amount of moles in this, but here is amount in grams. So this will give you mass concentration. This place gave you molar concentration. So for you to convert from here, they can ask you to find the molar concentration. What you have just calculated is the concentration in grams per dm cube, which is also called mass concentration. So the question can ask you find the mass concentration, then find the molar concentration. So if the question is also asking to find the molar concentration, you need to convert that mass concentration to molar concentration. And how do you do that? Going to convert this to molar concentration. The formula is molar concentration, which is concentration in mole per dm cube, is equal to mass concentration, which is concentration in gram per dm cube, all right, divided by molar mass. That is the formula for converting mass concentration to molar concentration. So if you are going to do that, you need your molar mass. So what's the molar mass of KOH? The molar mass of KOH will be potassium is 39, oxygen is 16, hydrogen is 1. So that's going to be 56. That is the molar mass of KOH. So now we want to calculate the molar concentration. So molar concentration of this is going to be mass concentration, which is what? 5.6 grams per dm cube divided by 56. That's going to be 0.1 mole per dm cube. Now take note. This is now the molar concentration, while this is the mass concentration. Let me now give you this difference. Molar concentrations are usually very small values, 0.1, 0.05, okay, very small value. It's very rare for you to even have 1 mole per dm cube. It's very rare cases. That's where you have 1 mole per dm cube. But when they say mass concentration is usually a bit high value. So this is 5.6. So when you do your calculation, the value you get, the answer you get will make you know whether your answer is correct or not. So if you are getting maybe 56 point something mole per dm cube, just be sure you're wrong. Or 5.6 mole per dm cube, no, it is grams per dm cube. But if you are dealing with molar concentration, then you have 0.1 mole per dm cube. I hope that is clear to everybody. So if you have not subscribed to this channel, please do well to subscribe to this channel, hit the notification bell, so that you can get our updates whenever we post any content. And if you have any question, please drop it in the comments. I will be back to respond to you. I wish you all the best in your chemistry exam. Bye for now.